Okay. So in this one, directly from this particular chapter, you might be expecting some 2 to 3 questions, direct questions from this particular chapter. But so what I insist on this particular thing is whatever you deal with in another chapters, whether these chapters concern to the second year or whether these chapters concern to the first year other chapters. So we'll be using these particular principles in everywhere, in every concept where related or in the different difference of your 11th class as well as your 12th class. Whether it is concerned to the buoyancy forces or that is fluid statics, or whether it is concerned to the some of the heat related questions or electricities, any other cases also we'll be using some of these concepts we'll be using. So coming to the NLM, that is the Newton's laws of motion. Today we'll be covering the applications of the Newton's law, some of the things, simple pulley questions. So not that constraint motions or constraint equation questions will be asked. He'll be going for a simple sort of a things only. Next, motion of a body on a rough surface. In the sense, we'll be discussing about the friction and on the frictional cases and on the inclined plane, the block on the block problems and the vertical circle. So actually, I just wanted to place this vertical circle in the work per energy because in dealing with the vertical circle, we'll be using the energy relationships. But in dealing with the sums, we have to use the force relationship also. So we just wanted to discuss this particular thing, vertical circle here itself. Fine. So now coming to the first one, directly entering into this one. So what are the applications of this Newton's laws? As everybody knows this particular thing. So Newton's laws are that is Newton's laws of motion or of the three laws. And the first law itself is going to be stating about the force. Okay, so he is going to define the force in the first law itself, where the body continues to move in its continues to take its position, whether it is a rest or of a uniform motion or of the direction, until and unless an external aid is being taking place. What do you mean by this external aid here? This external aid is nothing but this external force that he is indirectly defining over here. So this is the first primary thing that will be in the case. And coming to the second law of the second law, he is going to define the force F is equal to rate of change of momentum, that is dp by dt. And in this case, if we write d by dt is equal to mass into velocity, so it can be the mass can be variable or velocity can be variable on the differentiation if you can take this one. By keeping the mass constant, velocity of the variable, and it can be the velocity constant, mass can be variable. For example, you can go for the rocket propulsion or any other cases, things in this one, where the mass can be variable things, or a conveyor belt is also there, where the mass can also be the variable things. Okay, yeah, sorry. This is the one, please. Yes, somebody has been asking the doubt here. Yes, somebody raised the question, their hand. Okay, so now, so in the case where the mass is going to be variable, for the case of an variable mass conditions where the conveyor belt might be there and other cases. So in this cases, if, for example, if at all, if that is the mass is going to be m is equal to constant. So in this condition, then your rate of change of the mass will be equal to zero. And on that condition, you can take that F is equal to m into rate of change of velocity, which is nothing but an acceleration. We do write this one as an ma. If if at all velocity is going to be constant, if v is equal to constant, that is conveyor belts or all of them will be having the constant velocity. So in that condition, if v is equal to constant, then your dv by dt value will be equal to zero. Then f has to be equated with an v into that is dm by dt. So please be careful while reading the question which term he is mentioning it to be the constant. And for general uses, the same force can also be used as a F is equal to this is delta P by delta T, or the change in the momentum. This is delta P is nothing but an mv minus mu by delta T, or the change in the time. So here velocity, and both the velocities are the vector quantities. Since velocities are their vector quantities based upon their directions of the v and u, you decide whether to take a negative sign or a positive sign in this case. For example, if a ball is coming and hitting a particular floor or a surface like this and returning back, if the collision is an elastic collision, then the velocity or the magnitude of the velocity will be same, but the velocity direction is been different. In that situation, you can write F is equal to mv bar minus of minus this one mv bar. So it will be turned out to be as an it is 2 mv into delta t. Okay, so this type of the questions, so please be careful of this one. So, or else from the same relationship, you can also use this one as an force into delta t is equal to, that is change in the momentum, or it can be written as an mv bar minus mu bar. So I'm just brushing up all the basics of yours, please. So this is the one of the things, and force into delta t is nothing but called as an your impulse. So impulse generally they will do represent with a J is nothing but a maximum force or large force is acting for a short interval of the time, that is called as a change in the momentum. And your area of force and the time graph gives impulse or change in momentum. Okay, so this is the situation, sir. So you can have the dimensional formula, that is the impulse change in the momentum here. So that is J can be written as a force into delta T. Force dimension formula will be the mlt to the power of minus 2, which is nothing but a mass into acceleration part over here and into time. So that comes out to be the mlt to the power of minus 1. Okay. So this is regarding your second law of Newton's, where we have discovered about the force conditions, or for a variable force is there, then the impulse can also be obtained by the integral of F into dt. So to solve in this case, F has to be a function of time. So then only we can solve this one. For example, you can have that some F is equal to 4t like this. And what is an impulse in this particular case within the time interval of some 2 seconds to 5 seconds? These type of the questions, just you need to substitute J is equal to integral of it is 4t into dt, where the limits are being changing from the 2 to 5. Okay, so now you can integrate this one corresponding to that will become as a t square by 2. Substitute the corresponding values to t square. On limits first, generally we do to apply the lower limit and then further upper limit and then lower limit. So these type of the questions can be asked. Please be careful of that one. And now coming to our next type of the law is nothing but called as in your third law. Newton's laws of motion. Under the Newton's laws of motion, this is your third law. So coming to the third law, so we know that for every action there will be an equal and opposite reaction. That means your action and reaction are forces, sir. So these action and reaction are the forces, means they do not act on a same body or a single body. So if the action is being taken by somebody, then the reaction will be taken by the some other body which has taken your action. So from this you can say that force acting on the first body due to the second body is equal to force beyond the second body because of your first body, but both of them are magnitude wise same. but they will be in opposite in direction. Okay, so this is the Newton's third law under the. So as the we are going for an force acting on the one body to the other body cases. So we'll be dealing with that particular thing. So before going exactly that one, I like to deal with the law of conservation of momentum, law of conservation of momentum. In the sense, the conservation, if any external force acting, if dA external force is equal to zero, that implies according to the second law, dP by dt should also be zero. In that sense, dP, that is a change in the momentum zero, or you can also state it as a change delta P is equal to zero. What do you mean by delta P is equal to zero? Final momentum minus initial momentum zero, which implies your final momentum will be equal to the initial momentum. There are a lot of cases under this particular conditions, that is recoil of a gun. If you want to go for an example, it will be the recoil of a gun. So suppose if a gun is fired, before firing the gun, it will be in the rest position. That means its initial momentum will be equal to zero. So as the gun is fired, the bullet is going to be traveling in the forward direction, and the gun will be traveling in the backward direction. That is, final momentum is not zero. So if I want to find the final momentum, is going to be the mass of the gun into velocity of the gun plus mass of the bullet into velocity of the bullet is equal to zero, since initial value is zero. So from this one, you can say that the mass of the gun and velocity of the gun is equal to the mass negative of mass of the bullet and velocity of the bullet. The negative sign here indicates that if the bullet is going to be traveling in the forward direction, then gun will be recoiling. That is nothing but then coming in the backward direction. So recoil word means you are specifying that gun is coming in the backward direction. So if in the question he mentions that if the what is the recoil velocity of the gun, if in the question he mentions that what is the recoil velocity of the gun, then again you need not to put the negative sign. Recoil itself indicates that your gun is moving in the backward direction. Again, putting a negative sign does not going to the meaning, is going to give you the meaning. Because in the options he is going to go for an positive sign values and the negative sign values. So already he is mentioning that it is going to be moving in the backward direction. So you need not to choose the negative value terms, you have to go for the positive value terms. Or in another case where the man is jumping from the moving train or a stationary train, in that cases also you can use these particular things. So if you want to find the velocity of the gun is equal to how much, it will be the minus into mass of the bullet into velocity of the bullet by mass of the gun. So like this you can find it out. Or else, if both of them are moving in the simultaneously in the other case, so you can use the same situations. So depend upon this one. This is the law of conservation of the momentum conditions. Okay. So now coming to the relation between the kinetic energy and the momentum. So your kinetic energy, as I'm discussing about the momentum, I'll also brush up this one. Kinetic energy formula is generally it will be a relation is p square by 2m. That implies if mass of the body is equal to constant, then kinetic energy is going to be directly proportional to the p square. So that means if you plot a graph between the momentum and kinetic energy, it will be a parabolic in shape. Okay. And another examples of this one are you can take it as an uh, explosions. Suppose a bomb is at rest. Okay, you can consider different types of the examples here. For example, if a bomb is in the rest position case, I'm just taking it as an explosion. So if a bomb is in rest, and exploding, then obviously your initial momentum will be equal to zero. And after explosion, if it is turning out to be the some number of pieces, then it will be the m1 v1 plus m2 v2 plus m3 v3 is equal to zero if it is splitting up into the three pieces like this. Suppose if v3 has been asked, then v3 bar can be written as a, that will be the negative of minus m1 v1 bar plus m2 v2 bar by whole divided by, that will be equal to the m3. So these type of the things, please. So please be careful of this law of conservation of momentum. One of the very, very important concepts of this one, please. So you can also have the variable mass condition, that is the rocket propulsion also you can have, where you can use the relation of the rocket propulsion for a general cases if it is not given in the relative velocity conditions or any other case. Uh, Relative velocity and other cases, you can write it as an velocity of the rocket propulsion v is equal to initial velocity of the rocket plus the relative velocity of the rocket with respect to the ground into ln of, you can write it as an m naught by em at a given instant of the time, where v is the relative velocity of the rocket with respect to the ground, v u naught is an initial velocity of the rocket. So if all these stuff is not there, if generally he gives you it's moving with a constant speed, that is speed is not changing, then if he mentions that speed is not changing, then you can write thrust force is equal to thrust force, that is F thrust is equal to V relative velocity into this will be the dm by dt. So this is one of the most important things, please. Next one, next important in this one, if you go for an equilibrium condition, if you want to discuss the equilibrium situation, if anybody or if any system is in equilibrium, that means net force will be equal to zero. It doesn't have any acceleration. Acceleration will also be the zero. So this is the one of the most easiest thing. You need to just identify the forces, directions, and their magnitudes. Show that sum of all the forces along the x-axis is equal to zero, and sum of all the forces acting along the y-axis is also zero. So, and you can solve these equations for the corresponding things, please. For example, if I want to go for an equilibrium conditions, if a body is in if a body is in equilibrium, for example, if I just want to draw a diagram in this way, there is a simple pendulum has been simple example. I'm taking a simple pendulum is been suspended like this, and it is being pulled to sidewise to a force of some F is equal to your mg, and making an angle theta with respect to the vertical. So we need to find out the tensions here. So let this be the tension here T1, and let this be the tension T2 here. So these two are the tensions, please. Then component of the tension that will be acting in the upward direction is T1 cos theta, and this is also theta value, and in this direction it will be the T1 sine theta. You can equate that T1 sine theta is equal to your mg. From this one you can get the T2. Sorry, T1 is equal to this will be the mg by sine theta, and from the same diagram downward force T2 is equal to upward force T1 cos theta. In that sense, T2 is equal to T1 if I replace mg cos theta by sine theta, that is equal to the mg tan theta. Okay, so these type of the things for the equilibrium, whenever it is under the equilibrium, just you need to equate the forces along their specific directions. That will be the more comfortable conditions. Okay, suppose if this lift is in the accelerated motions, if I go, If the same pendulum is being placed in a lift, so which is called as an apparent weight. So if the lift is been moving in the upward direction, so and the pendulum, what does it have? It will have the mg in the downward direction, and in the upward direction, it is moving with a certain acceleration, tension in this one. So with respect to the inertial frames or non-inertial frame, whatever you write it, for the person, if I'm going for the inertial frame, for the person who is standing on the ground, he sees that lift is going in the upward direction. The upward force is T. So according to his observation, T has to be greater than the mg. Because of that reason, it is moving in upward direction is equal to ma. Now T is equal to m of G plus A. This type of the equations you can get it, please. So these type of the questions where the net equilibrium or the system is in equilibrium, you can solve this one. And in the same case, apparent weight, this is moving upwards. Now when lift is coming down, then the same relationship can be written as a T is equal to m of G minus A. So where your apparent weight will be changing in this cases, please. So these are all the cases where your net acceleration of the acceleration of the system is equal to zero. For example, if you want any particular situation where the bodies are going to be accelerated conditions, then it will be another cases, please. In this, for example, two blocks accelerated bodies. If the bodies are being placed on a level surface like this, and I'm applying the force on them, let one of the force is going to be the m1, another force is going to be the m2. So they are moving with a force like this force, and acceleration is in this direction. So from the system, you can say that acceleration of the body is equal to force applied by, that's going to be the m1 plus m2. So from this one, you can say that force applied, that is acceleration of the body is equal to F by M1 plus M2. So this is a situation, please. Net acceleration of the system. So if you want the contact force between them, you need to go for the FBD's free body diagrams. Let this be the M1. If I apply the force of F on this side, and acceleration on this or another force, that is your normal reaction, is in this direction, then the n value can be equal to this can be written as an f minus n is equal to m1a, and similarly n is equal to m2a. So if I put down the m2a, then again we need to find, so from this one, acceleration of the force can be written as an, this is a into same thing m1 plus m2. So this is what I have written over there. That will be the same situations, please. So coming to the string problems, simple pulleys. The output machine is the one which is a basic pulley method. A one pulley is being hanged from the situation, so or else it is being hanged like this. So now what should happen here? Suppose if two bodies are being connected here, if two bodies are being connected, then what will be the acceleration of the one of the body, and what will be the acceleration of the other one? So let us take the two bodies over here, which is m1, and another one is going to be your m2, where if I consider that m1 is greater than m2 and having a tensions in this one as a t, then then you can find out the acceleration of the system to be a is equal to how much, sir? A is equal to, you can get it as an m2 minus m3 by m2, sorry, acceleration m2 minus m1 or m1 minus m2, anything greater value minus smaller value, or if you take the m1 as greater, then m2 will be obviously smaller. M1 minus m2 by, this will be the m1 plus m2 into g. So this is acceleration, and tension will be equal to the 2 m1 m2 by m1 plus m2 into g. Okay, so these are the output machine conditions. So you should be very careful of them. For example, for the another pulley constraint, a block is there on the table and it is being run over a pulley like this. And on the other hand, there is another block here. So now this be the block A and this will be the block B. For this type of the system, acceleration can be directly obtained by A is equal to, that is net external force or net external force by total mass. So for this one, what will be the acceleration? A is equal to mb minus ma by greater value minus smaller value, or else it can be ma minus mb also by this is m1 plus m2 or ma plus mb into g. So this is how you can get the acceleration. But in this case, you cannot have the situation. In this case, you don't have the mb to be applying any force. So that means you can remove this particular thing. So your acceleration will be m by m1 plus m2 into g. Okay, so this is the one of the things, please. So there are the certain lot of different applications in this case. For example, if I go for another case, for example, if you go for another case, two blocks are placed on an inclined plane. Inclined plane means the two like this. This is going to be the angle theta one, and this is going to be the angle theta two. Then, if this is going to be the M1, which is being on a circular patch like this is your mass M2. So M1 and M2 are their angles making a theta 1 and theta 2. Then what will be the acceleration is equal to, acceleration can be written as n. So what can be the formula? Net applied forces. This will be the M1g sine theta 1 minus this is M2g sine theta 2 by total mass, that will be the m1 plus m2, and your tension will be equal to the 2 into this is m1 m2 into that will be the m1g1 sorry m1g sine theta 1 minus this is going to be the m2g sine theta 2. So this is your basically these are the different formulas for different situations. You can extract the different formulas different situations, you can analyze and you can write, or else you need to go for the block diagrams if you cannot remember them. So first step, you have to identify the block diagram, uh, block diagram FBD, you need to draw that one and identify the forces correspondingly and find out the resultant force. If it comes to the rest, you can say that the particle is in equilibrium, or else if it is moving, then it's called as an accelerating bodies or accelerating particles. Okay, so these are some of the things, please. Next one, these are your constraints or whatever it may be the method you can have. For the accelerated motions, so simply one thing will be there. If a body is been moving with a certain velocity, what will happen to its acceleration? Constantly it is been moving. So constantly it is been moving in the sense, you need an external force to stop that particular thing. That's nothing but called as an your frictional force, that sort of things, please. So for any accelerated motion, there will be have some resultant force, that is F minus mg, F minus mg, that is okay. So that means resultant acceleration will be always F minus mg by m. So resultant acceleration means definitely it will have some sort of an acceleration, and definitely it will have some force. The both the forces are F and mg are not equal. Either they not be not equal vectorially, in the sense their velocities or their values may not be same, or any other cases. It is a generalized situation, please. So next topic is the block on a block. So before going for the block on a block, we'll be seeing the sums on this particular thing. That means some examples on this one. So what is this frictional case? Whenever an object is placed on a surface like this, so if If until it is not moved, then we also don't know that it cannot move. Okay, but if some force is been applied on this block of force F and a mass M is being applied on this one, and if it is reluctant to move, that means some opposite force is been acting in the opposite direction. So that is called as your frictional force, which acts tangential to the surface, which will be always which will be always opposing the relative motion of the body with respect to the surface. So relative motion is going to be indicated on that particular issue. So this is called as an coefficient. This is your normal reaction n and the result between both of them. So your frictional force formula it only depends upon the normal reaction mu mg into mu n, where n can be any value, that can be the mg, n can be mg cos theta. So like this, it can be any particular thing, please. So on this angle, the angle between the normal drawn to the resultant of normal and normal reaction with respect to the normal, this theta is called as your angle of friction. Here theta is called as an the angle of friction. Okay, so this is then it can be defined as that it is an angle between the normal reaction and the frictional normal reaction and the resultant of normal reaction and frictional force. So this is your angle of contact situation. What will be the displacement if you have the friction? Displacement will be S is equal to U0 half EA T square. So in this case, A can be written as an for horizontal cases, A can be replaced with the mu G conditions. Fine. So next one, there will be three types of the friction that we know. In that one, kinetic friction, static friction, and the rolling friction will be there. There are three types of the frictions. So first, I'll be going for an kinetic friction, since it will have the more opposing thing. That is an what is this one? Static friction is same. Static friction is equal to mu s into this is mg into yeah. This is static conditions where the maximum value of the static frictional force is nothing but an applied force, or until the applied force is sufficient then the body does not move. Since the body is not going to move, it doesn't mean that we have applied the force. We have applied the force in this case also to move any body who will overcome the friction conditions, please. So for horizontal surface, you can write it as an F is equal to half A T square, as this is half into mu G into T. Like this, you can replace the acceleration value at any particular instant. Time to stop it, that is U by A is equal to. So you need, sorry, you can just put down these certain values. The time to stop any particular cases. Suppose final velocity is equal to 0. V is equal to U plus AT. From here I have written that one. Since it is 0, your AT is equal to U. T is equal to U by A. So this is the time where it can stop over there, because your final velocity is going to become 0 at that particular point. If some resultant force is there, then you will be considering the, or else you will be equating it to the rest case. Fine. So next one, in this current condition, the coming to the block on a block, if a block is placed on another block like this and it is being pulled aside, suppose this is mass is m2 and this mass is m1. So if it is being pulled and then in this case, or a force is being applied on this one or on the upper side of the block, then what will happen if there is no friction and here there is a friction? In this case, there will be three cases. If applied force is less than the frictional force, that is mu mg, then the frictional force is then the frictional force is equal to the applied force. It will be that is equal to the ma. So because the static frictional force is a self-adjusting force until certain value. So whatever may be the applied force is there, the same force will be uh, given to this one, please. So, and that is your applied force, which is also equal to your frictional force situations. Fine, sir. Next one, in the same block on a block conditions, if I apply the force on the bottommost block, that is, if M2 is applied, this is going to be the M1. So if the force is been applied, it yields a pseudo force with its own mass, that is MA naught, and correspondingly the friction might be acting in the forward direction. Okay, so you should be very careful in applying the block on a block conditions. You should see whether the applied force is greater than your frictional force or any other forces. If at all, if the applied force is less than that frictional force, the body cannot move. If the applied force is equal to the frictional force, then the body is going to be just tending to move. So then the values or whatever is going to be different than the initial static conditions, because static friction is highest than the kinetic friction. So please remember those points and try to solve them separately, please. So in this case also you can write the net acceleration if both of them are not moving. Then this will be the applied force plus frictional force by total mass is going to be this is the case. Okay, so these are your conditions for an inclined plane. Suppose if we go for the block, a wedge condition, suppose an inclined plane is there like this, which is making an angle theta, and there is a block over here. If it is sliding down the inclined plane, then you can write the acceleration. Then you can write the acceleration of the system A is equal to this is g sine theta minus mu cos theta. So acceleration in coming down, and the same acceleration is going to be moving up. Moving up is equal to g into sine alpha or sine theta minus mu into mu plus sine. This is when you want to move it in the upward direction. Okay, now so it will be the sine theta plus mu cos theta. This is up the inclined plane. This is down the inclined plane. Okay, this is your basic acceleration relations. Corresponding with the acceleration relations, mm, instead of it's a rough surface or frictional surface, if the inclined plane uh, is smooth, then acceleration comes down to be the g of sine theta, because your coefficient of friction will become zero in these cases. Fine. So there are the different applications in this one. In this what you call situation, then so please be careful if it is a rough surface or a plane surface. So velocity on a rough surface is equal to, you can write it as a root over, this will be the 2gl of sine theta minus mu cos theta. So these are your situations, please. From this one, you can also find the time period or different cases. So what is the minimum force? Minimum force on a block over here or to move this one. So you have to move this one by applying a force of S. What should be the minimum focus? This is the situation F, and in this direction it will be the F cos theta is the one which is going to be the applied force, and F sin theta is in the other direction, perpendicular to the F cos theta. In that direction, there should be normal reaction. Downward force is going to be the mg, and n plus F sin theta is equal to mg. So from this one, n is equal to mg minus F sin theta. So substitute this n in the friction force. F is equal to mu into n. Mu into n. Substitute this n value, you can get the frictional force conditions. Okay, so like this, you need to balance the equations in which there is no resultant force or net force is becoming zero. So please identify those things and write down the equations. Mu is equal to F is equal to mu naught into n. Okay, so these are the basic examples, some of the things we have seen in an NLM situation. So body on a rough horizontal surface, as I have discussed, a body on a rough horizontal surface in horizontal inclined plane. A rough surface means motion of the body on the rough surface. Such horizontally or inclined conditions means. So how do you define this particular motion of the body? How the body is been moving on the horizontal surface or on the inclined plane? Okay, so what? How does it will be on a rough surface? Means friction will be definitely there. Then applied force is equal to mg minus uh, force only. He is asking, sir, on a rough surface. In this case, I need an applied force on this one. Let me draw the block diagram here, please. So coming to this one block diagram, so you can draw this one. Okay, there is a block over there which is tends to move on a rough surface with an initial velocity u, and after traveling some distance on a rough surface, if its velocity becomes zero. So why it is velocity is becoming zero? Because it is traveling to some distance. In this distance, the friction force is stopping it. So the acceleration of acceleration where you can apply this particular situation, that is a is equal to v minus u by t. U is equal to zero. It is v by t. So acceleration can be written as, and this is mu g is equal to v by t. That is v is equal to, this is mu gt. So like this, if you want to find the velocity at any particular point, if you want to find the displacement also, if you want to find the time period also, you can use these relations properly, please. Okay, so what is the minimum force required to move a block on a horizontal surface? The minimum force required, that is the minimum required to pull a block, will be F is equal to, this is theta, and this is F cos theta, means upward force is equal to F sin theta, and the downward force is going to be the mg, and the normal reaction n. Okay, then you can write it as an n is equal to mg minus F sin theta. Mg man and normal reaction. Now from this one, you can write the frictional force is equal to mu into n, which is equal to the mu mg minus mu F cos theta. In sorry, mu mg sin mu mg is the one which is the frictional force, sir. So now this is your angle and minimum force if I want. Then you can apply in any case normal reaction. If I substitute here, substitute the normal reaction in this place, please. So what is the formula for the normal reaction that we have got? Mu is equal to mg minus f, that is f sine theta, and applied force will be equal to the f cos theta is equal to mu into normal reaction. That is f cos theta is equal to mu into normal reaction is nothing but an mg minus mu into f sine theta. From this one, f can be eliminated as, and this will be the mu mg by, this is g of cos theta plus mu sine theta. Okay, so this is your minimum force required to pull a block. So these type of the questions can be asked, please. And your last concept of this one is an vertical circle here. What is this vertical circle? When a body is made to move in a circle, that too in a vertical plane, that means G will be acting on it constantly. So let this be your highest point on the surface here, and this is your lowest point, that is A. Let this point be B. So when you are moving this particular block from the bottommost point to the highest most point, you need to give some velocity to it. With this velocity, considering this to be the ground level, then it will have the total energy in the form of kinetic energy, and the TE of the repeated is equal to, that is the total energy of the system will be equal to the mgh plus, that will be the half mv square, since it's the bottommost point, h is equal to 0. So from this one, that will be the half mv square. So this is your total energy at the lowest point, that is at the A. and then the total energy at the highest point B will be equal to the mg into 2r plus minus, if it is having some velocity, half mv square at the maximum height. So while equating these two things, you can solve whatever is going to be asking you. So or else velocity at the highest point can be written as a root over at where or velocity at any particular instant. In this case, how do you write the force equation T, and downward force is equal to mg cos theta, and this will be the mv square by r. So then from this only you can determine the velocity at any particular instant, that will be the equal to the 3 plus 2 gr. This is cos theta conditions. And the tension also, it will be in the same sort of a model. T is equal to, that is 3 plus 2 mg. So these are your basic information or basic standard values. Try to remember them for a vertical circle. So in the vertical circle, law of conservation of energy and law of conservation of the momentum both will be satisfied. Law of ఈ రెండు కూడా satisfy అవుతాయండి. So please be careful in applying those relations, please. So now here, if you want to find out the tension or velocity at any instant by making an angle theta, you can use these relations. For example, I'm using this one. T is equal to, it will be the mg cos theta plus, that will be equal to the mv square by r. Velocity is unknown value that can be obtained by the law of conservation of energy. Energy at the lowest point will be the half m lowest square is equal to, this is at an angle theta. At that angle theta, it will be the mgr or mgl into, that will be the 1 minus cos theta plus, this will be the half mv at the theta value square. So substituting the velocity or obtaining the velocity from here, substituting in the tension, you can get the tension value is equal to how much, or else you can replace the cost value of sine wave. So these are the majorly two equations, and the connecting thing that will be in both of them is going to be the v theta, that is velocity at that theta instant. Okay, so now with this one, I just want to conclude this particular session. Please go through the NLM. For any equilibrium bodies, the net acceleration will be zero either along the x-axis or along the y-axis. You just need to identify the forces and equate them and show that net acceleration is equal to zero. Or for accelerated motions of the bodies, you will have that for different accelerated bodies, different type of the acceleration. So for the accelerated bodies, you'll have some resultant force. There is some resultant force is there. There is some resultant acceleration will also be there, and correspondingly velocity and whatever is going to be there. So please be careful. Read it very carefully. And from by here, I'm just leaving this particular thing. Thank you for everything. All the best to you for the coming examination. Bye, each and everybody.